Okay, so I wanted to start off today because we're hitting that point in the semester where spring breaks and other days off hit. I want to make sure you're all aware. Your people at your school should be aware because we've sent out updates. But I want to make sure you are all aware of what our schedule looks like for the next few weeks at least. First of all, today is going to be our last day of class for about a week and a half. This Friday, March 11th, there will be no class. Austin is out of school that day, and Durand was scheduled to be out of school that day. They're not part of the picture anymore, but I made some appointments for myself that day because of that. So there's no class on this Friday, March 11th. Then next week, that'll be March 14th through 18th, is our college spring break. Now that works out well for Clear Lake because that's your spring break as well next week. So we'll get to enjoy that time off. Clayton, you guys I think have Monday off that day. It was also Durand's spring break, but like I said, they're not in the picture anymore. So for the other 2 days next week, Clayton, you guys will just have a free period, a study period. Mauston, you guys have a choice, because I realize your spring break is the week after that, the 21st through the 25th. You guys have a choice. You can do one of two things. Either next week you can look ahead on the material for your spring break, so that work ahead for March 21st through 25th. I sent the videos and the assignments to Mr. Paulus there and Mrs. Mead. So they have those for you if you want to get them from them. Otherwise, you can get them directly off of Blackboard. You can pull those out go into course information and scroll down to week 9, right after our spring break. So you can view lecture videos of what we'll be covering that week and the homework. When you guys come back on the 28th, there will be some time to review before we hit a unit test. So don't worry about that. There will be plenty of time. We'll do a lot of example problems and stuff like that before we hit a unit test. That'll take us to the end of March. April is going to be another weird month because Easter breaks are always different. So we'll take a look at how that'll be done. There's going to be a few days that we take off in April as well. Unfortunately, for some of you, there'll be some days that you're off that we won't take off. Hopefully it'll all even out before we're done. So just so you guys are aware, does anybody have any questions on the schedule for the next few weeks or for the rest of March here? After today, our next class is March 21st. Now, as I said, from Austin, you guys are welcome to work ahead next week since you guys will be in school and we won't be. You're welcome to work ahead, or if you would prefer to use the time next week as study periods for other homework, and then log in from home during those classes, March 21st, 23rd, and 25th. You are also welcome to just log in from home those days as well using the links are posted on Blackboard. If you have any questions, you can send me an email and I can send you the links and everything directly. Just to make sure you have everything correct.
Us from Mauston are going to probably just work ahead because we're all three going on vacation.
Okay, so that would work fine. Those videos, do you guys know how to get into Blackboard to get the videos, or do you want me to show you again?
We know how.
Okay, Yeah, it'll be listed as week 9. It'll be listed as March 21st to 25th, so you should be able to find everything right there. I'll make sure everything is updated for you. Okay, so with that, then let's go ahead and start our material for today. We are hitting the heart of things. Like I said, we've done the dilutions, the solution, concentration adjustment formulas, and all that. Today we are actually going to start dosage calculations. One of the precursors to dosage calculation is understanding constituting a solution. When we constitute a solution, it might be said that we are going to shipping costs basically cause us to ship things in the lightest form possible. So we might get a vial of solution, and it might just have a little bit of powder in the bottom of the vial for medication. The label will tell us how to constitute that. It might say constitute or reconstitute with 4.8 milliliters of sterile water to 25 milligrams in 5 milliliters. What this is saying, constitute with 4.8 milliliters of sterile water. It's saying add 4.8 milliliters, take a needle and inject 4.8 milliliters of sterile water or normal saline into this vial and mix it up. To 25 milligrams in 5 milliliters, that is saying this will be the concentration once we have added that 4.8 milliliters and mixed it. Really, the only important part for us at this point is what that final concentration is going to be, 25 milligrams and 5 milliliters. The other part that is important to understand is medical abbreviations. Now, I am not going to test you on any of the medical abbreviations, but it might be important to understand some of them in order to understand how to do the dosage calculation. These, by the way, are in your textbook on page 150. That's a page that wouldn't hurt to mark because you may have to refer back to it to understand doctor's orders for medications. Abbreviations might be things like PO. PO means that the medication is to be taken orally. Or one that we're going to use a lot, IV, of course, intravenously. So in other words, injected into the vein. Or IM, intramuscularly. Injected into a muscle. So you don't have to worry about finding a vein, just anywhere into a muscle will be absorbed. That is the means of administration. The only one that really matters to us is intravenously, because that means we're going to have to calculate a flow rate rather than just a flat dosage. Ones that are more important to us are the ones that would indicate a frequency. Q4H, for example, every 4 hours. PRN, as recommended or as needed. Q6H, Q8H. Just like the Q4H every 4 hours, of course, is every 6 or every 8 hours. There are abbreviations, 2IB, twice daily, things like that that you should be refreshing on. Like I said, I'm not going to test you on them. I'm not going to spend a lot of time here going over those abbreviations. But that page 150 in your book is one you should mark and take a look through it, read it, be familiar with them at least, so some of the more common ones as they come up, you'll understand what the doctor's orders are saying. Now let's get to actually calculating the dosage from our doctor's orders. And what we're doing in all of these cases, we are taking a doctor's order and we are interpreting what the doctor's order is in terms of what we have on hand in order to administer to the patient. The doctor will never say give 2 ibuprofen capsules to a patient. They will say give so many milligrams of ibuprofen to the patient, because the doctor doesn't know what size pills you might have in the drug cabinet behind the nurse's station. You might have 500 milligrams, you might have 800 milligrams. Also saying 2 or 3 pills, capsules, could be a very different dosage depending on what the supply is. So the doctor will order an amount either usually in milligrams or grains or some other very specific amount. And then it has to be interpreted by whoever is giving that medication, administering that medication, in terms of what the supply is. Now we have 3 main methods that we are going to use for calculating that. First method is probably my least favorite. It's one of those it's very prescribed and requires some memorization, but it's very unflexible. It can only be applied in certain situations. That's why I don't like it. I like methods that can be used for multiple situations. This method 1 is the dosage formula. I'll just let you in. I'm going to be giving these in the reverse order of my preference of using them. The last example I do is going to be my favorite method of using. You guys are welcome to use any method that you like to do dosage calculations. I will tend to lean towards the last one we do, which will be dimensional analysis. But if you guys want to see examples done in any of these other methods, let me know. So the dosage calculation formula, P over H times V equals A. Well, what do each of those values mean? Well, D is doctor's order. H is the on-hand dose. Color here, V is what we call a vehicle. A vehicle is what carries the medication into a patient. Whether it's a capsule, pill, an IV, a fluid, injectable fluid, whatever. It's what carries that amount of medication into the patient. The on-hand dose and the vehicle are typically linked together. Both are part of the label on our bottle or vial of medication. Then A is what is actually administered to the patient. So you can see this follows our chain. We are starting with an amount that is ordered, doctor's order, and proceeding through to what is administered to the patient. This dosage formula is very, very linear going across that continuum. The on-hand dose and the vehicle can be a little confusing. A couple of examples here. Let's say the doctor's order is for 500 milligrams ibuprofen. And our supply, 200 milligram capsules. So to apply our formula, D, doctor's orders. Well, that was pretty straightforward. That is the 500 milligrams. The vehicle, and the on-hand dose and the vehicle, like I said, both tend to come off of the label on our bottle or supply. Both of them are given right there. 200 milligram capsules. 200 milligram is the on-hand dose. Capsule is our vehicle, 1 capsule. So you can see the vehicle is what carries that amount of the single on-hand dose. So the vehicle and the on-hand dose are linked together that way. One thing I should note is the doctor's order and the on-hand dose must have the same units. If they don't, we have to convert something. Because for this formula to work, these units must cancel out. So the milligrams and milligrams cancel out. Then we have 500 divided by 200, which is 2.5, times 1 capsule. 2.5 times 1 capsule is 2.5 capsules. So we would give 2.5 capsules of medication to that patient for that 500 milligram dose. We might have a doctor's order to administer 200 milligrams of medication. And our supply, looked at the label, 200 milligrams IM intramuscularly, so injected. We look at our label, it might say 25 milligrams in 8 milliliters. So again, we would start out with the doctor's order, 200 milligrams. The on-hand dose, again, comes from the label. It must have the same units as the doctor's order, so that asks you the 25 milligrams. Then, of course, the vehicle is what carries that on-hand dose into the patient. That'll be the 8 milliliters. So we put 8 milliliters over here for the vehicle. And then we just simplify this formula. So the milligrams cancel out. 200 divided by 25 is 8. That 8 times the 8 milliliters is 64 milliliters. So that to get that dosage, we would have to inject 64 milliliters intramuscularly into that patient. You can see both of those calculations were pretty straightforward and pretty simple. That is one of the strengths of the dosage calculation formula, is for simple calculations, very quick and very straightforward. Weakness is that in more complex calculations, it might need to be applied twice. So if there's or more times, if there are several steps, several levels in the concentration of the dosage, we may have to go through more than one application of the dosage formula because we can't get directly to what is administered to the patient. I'll show you an example of that. Let's say our doctor's order is to administer 200,000 international units to the patient. We know that we have a concentration. So we look at our reference. It tells us for that medication, 100,000 international units in milligrams. Then we might look at our supply, which might say that we have, let's say 8 milligrams, 5 milliliters. So here, this dosage calculation formula would not handle this conversion all at once. It would have to be applied multiple times. We'd have to start out with the doctor's orders, 200,000 international units. Over, now the on-hand dose has to be the same units as the doctor's orders, so we're going to use the 100,000 international units. And the vehicle that contains that is the 2 milligrams. So if we calculate this out, 200,000 international units divided by 100,000 international units. Well, the international units divide out. 200,000 divided by 100,000 is 2. At 2 times 2 milligrams is 4 milligrams. What that is telling us is that we're really being ordered to administer 4 milligrams to that patient. Well, to figure out what actually gets administered to the patient, this is now going to be our new doctor's order. So basically, we use the dosage calculation formula once to convert the doctor's order into milligrams. Now we're going to figure out how many milliliters we inject into the patient. Our supply is 8 milligrams and 5 milliliters. Well, 8 milligrams has the same unit as our order. And then the 5 milliliters would be the vehicle that carries that 8 milligrams into the patient. Milligrams cancel out. 4 divided by 8 is 0.5. 0.5 times the 5 milliliters is 2.5 milliliters. So for that order and that medication, we would apply 2.5, or we would administer 2.5 milliliters to the patient. So you can see that dosage calculation formula for that more complex problem required us to use the formula twice. Now that was just a 2-level problem. We will have problems that are 3 or 4 levels before we're done here, especially when you get into IV solutions and drip rates, flow rates. In fact, often there are separate formulas given that are applied to that other than just using dosage calculation multiple times. The other weakness of that formula, not only does it have to be applied multiple times in cases, but it's also one that you have to memorize. Our next process is one that's a little bit better because it doesn't require quite so much memorization. That is a proportion. And a proportion allows us to do that calculation without memorizing a formula as well. And it allows us to go from the doctor's orders to what's going to be administered to the patient. But it's set up a little different. In the proportion, we have our on-hand dose and our vehicle off the label. So the label will be the first ratio in our proportion. Second ratio then, now the on-hand dose has the same units as the doctor's orders, so they both have to go together. They're going to both be on top. And then what's administered to the patient has the same units as the vehicle. That's going to go on bottom. So let's look at similar examples here. So our order, once again, 500 milligrams of ibuprofen. Our supply is 200 milligram tablets. So, to set this up, we would take our supply, 200 milligram tablets. That's a ratio or rate of 200 milligrams for 1 tablet. On the other side, we put the doctor's orders. It's in milligrams, so it matches with the 200. 500 milligrams goes here. and then we cross multiply and divide. So 1 times 500 divided by 200, 0.5. The units will be the same as this unit here, tablets. Same result we had with the dosage calculation formula, just we didn't have to memorize a formula. We have an order for 200 milligrams of medication. A supply, like we had before, of 25 milligrams and 8 milliliters. Once again, we start with the supply. 25 milligrams and 8 milliliters is our first ratio. On the other side, the doctor's orders are in milligrams. Has to go with the other milligrams going on top. Whatever ends up down here will be milliliters to match up with this. And we cross multiply and divide. 8 times 200 divided by 25 will be 64 milliliters. So as you can see, that proportion, you don't have to memorize anything. It's just a matter of setting up our supply as a ratio and then matching things up on the other side with it. The doctor's orders should have the same units as one of those numbers. Match it up. It should have the same units as the on-hand dose if we set it up correctly. And then what is administered to the patient should also have the other units, which would be our vehicle. The proportion method has one of the same weaknesses, that it often has to be applied multiple times in a complex situation. Going back to the example, if our order was for 200,000 international units, we look up, and for this medication, it's 100,000 international units. In number here, 2 milligrams. And our supply, 8 milligrams in 5 milliliters. So we would start with, we would start with any of them, but actually let's go ahead, we'll start with this one. 8 milligrams in 5 milliliters. To keep consistent, we'll start with our supply. Well, we need to convert from milligrams to something else. The only other milligrams we have, we don't have anything else that's in milliliters. The only other milligrams we have is this 2 milligrams here. So let's put 2 milligrams. And we'll work our way backwards. 5 times 2 divided by 10, this will be milliliters. Sorry, 5 times 2 divided by 8 is 1.25 milliliters. What we have done is we've converted this 2 milligrams to 1.25 milliliters. Next proportion, we have the 100,000 international units is equivalent to, instead of 2 milligrams, we put in the 1.25 milliliters. On the other side over here, we have international units in the doctor's orders, 200,000. Down here to match up with that, and we cross multiply and divide. 1.25 times 200,000 divided by 100,000, 0.5 milliliters. So here's a case where the proportion has to be applied twice. And I think this is actually even more confusing. I like the proportion better than the formula. But this is an example where it's even more confusing than the formula, because if you start with the supply, which is where we're supposed to start with our proportion method, we have to understand this intermediate step where what we're really converting here is this intermediate step, not the final result. So we're replacing one of those two numbers with the result of the first proportion to start our second proportion. This part here doesn't necessarily make a lot of sense at first unless you really dig into the proportions. That brings us up to our third method, and my favorite method. I think the most useful because every dosage calculation problem we will do in this class can be solved with dimensional analysis. Dimensional analysis is something we did in Unit 2. I mean, we did some ridiculous dimensional analysis with just canceling units and stuff. But every one of our measurement conversions was dimensional analysis. If we said that 1 fluid ounce, 30 milliliters, if I wanted to convert 100 milliliters into fluid ounces, I use dimensional analysis. I put my 100 milliliters over 1 to make it a fraction. Getting rid of milliliters, so I put milliliters on bottom. We're going into fluid ounces, so they're going to go on top. We use this equivalency. 1 fluid ounce is 30 milliliters. Then we canceled units. The milliliters canceled. Multiplied it out. 100 times 1 fluid ounce is 100 fluid ounces. On bottom, 1 times 30 is 30. And then we had to divide that out. 100 fluid ounces divided by 30 is 3 1/3 fluid ounces. Well, we use that same practice, same process to do dosage calculations. We're simply going to start with the doctor's orders. And we're going to use equivalencies, conversion factors, if you will, get to what is administered to the patient. Let's look at our examples again. Doctor's order, 500 milligrams ibuprofen. Supply, 200 milligram tablets. I should note when we're using tablets, typically we would have to round. This one is worked out so it comes out to a half tablet. But if it doesn't come out to half a tablet, typically we would have to round to half a tablet because most of the time it's impossible to cut a tablet more precise than either it's a whole tablet or it's a half tablet. We will go over that before we're done with our examples in the coming classes. But anyway, to run this one through dimensional analysis, we start with the doctor's orders. 500 milligrams. Not a fraction. I will make it a fraction by putting it over 1. Some of our examples that we'll see coming up will be 8,000 milligrams over 12 hours. Well, that's already a fraction. It's a rate. 8,000 milligrams over 12 hours. Here, this one is just a single dose, so we have to make it a fraction by putting it over 1. Then we use an equivalency to convert it. This is an equivalency. It is saying that 200 milligrams is equivalent to 1 tablet. So we can now use that. Milligrams are on top. We're going to put milligrams on bottom so they cancel. 1 tablet. Milligrams cancel out. On top, we have 500 times 1 tablet. 500 tablets. On bottom, 1 times 200 is 200. And we divide that out. 500 tablets divided by 200. 0.5 tablets. So same answer we had with the other two methods. This actually may be a touch more work than the original dosage calculation method, but we'll see its strength coming up in that complex example. Again, in an order for 200 milligrams of medication, we have a supply of 25 milligrams in 8 milliliters. Now, once again, this label on our supply is giving us an equivalency. 25 milligrams in 8 milliliters, saying 25 milligrams of medication is equivalent to 8 milliliters of fluid. Now we can go ahead and start out with the doctor's orders of 200 milligrams. Once again, it's not a fraction, so we make it a fraction by putting it over 1. Then we use this equivalency as a conversion factor. Milligrams here, so we're going to put milligrams on bottom to cancel them out. 25 milligrams is equal to 8 milliliters. Now the milligrams cancel out. On top, 200 times 8 milliliters, 100 milliliters. On bottom, 1 times 25 is 25. And then we divide that out. 1,600 milliliters divided by 25. 4 milliliters administered to that patient. So nothing to memorize there. No formula to memorize. No awkward setup with the proportion. Like I said, that's the main weakness of the proportions. It can sometimes be awkward to figure out what goes where. It's just like we did with our measurement conversions before. We might have an order like our complex problem. Doctor orders 200,000 international units. Again, we look this up in a reference. 100,000 international units. Equal to 2 milligrams. And our supply, I might say that we have 8 milligrams and 5 milliliters. I want to make sure I use the same numbers. 8 milligrams in 5 milliliters. Here, no question as to where we start. When we do dimensional analysis, we always start with the doctor's orders. 200,000 international units. Now, since that's not a fraction, we make it a fraction by putting it over 1. Then each of these others is an equivalency. I mean, I actually wrote this as an equivalency, putting equal signs there. When it says 100,000 international units in 2 milligrams, that means 100,000 international units is equivalent to 2 milligrams. And down here, 8 milligrams in 5 milliliters, I can just say 8 milligrams is equivalent to 5 milliliters. Now we're getting rid of international units, so we'll put them on bottom. 100,000 international units equals 2 milligrams. 100,000 and 2 milligrams. And then I need to get rid of so the international units cancel out. I need to get rid of milligrams, so I'll put them on bottom. 8 milligrams equals 5 milliliters. 8 milligrams and 5 milliliters. Milligrams now cancel out. Now I could go ahead and just multiply this out and divide, but I'm going to do a little bit of reducing just so I don't have numbers that are big for my calculator. There is 5 zeros there, 5 zeros here, so I'm going to cancel this out. So this is just a 2. On top, it's going to be 2 times 2 times 5, 20. My only units there is milliliters. On bottom, 1 times 1 times 8, and all of the units have canceled out there, so that's just over 8. 20 milliliters divided by 8 is 2.5 milliliters. So you can see here, the dimensional analysis method was able to do this calculation all at once. There was no awkward middle step of how do I get it into a second proportion or where do I start my second dosage calculation formula. It's all one shot, and it's just a matter of matching up the units. Here's the units I have, so I have to find something that includes that so I can get rid of it and just keep going until I get to a unit that is something I can administer to my patient. This dimensional analysis is even more powerful when we start to get into dosages based on weights or based on body surface areas or intravenous doses. Things like, let's say we have an order for 1,000 milligrams to be administered over 6 hours. And let's say our supply is, well, let's go 50 milligrams in 9 milliliters. And let's say our machine, our infuser, set up in milliliters per minute. We have to be able to express this as how many milliliters are we going to infuse per minute. We'll start with the dose. This actually is already a fraction at 300,000 milligrams for 6 hours. Convert, well, I need to get rid of the milligrams. Milligrams are on top, so I'll put milligrams on bottom. This is saying 50 milligrams in 9 milliliters. So 50 milligrams, 9 milliliters. Milligrams have now canceled out. Right now what I have, and this is just like our compound units or our rate conversions we did in units. Right now I have milliliters per hour. I want milliliters per minute. So the milliliters are fine. I need to get rid of the hours. Hours are on bottom, so I'm going to put them on top. 1 hour being 60 minutes. Hours cancel out. I now have milliliters per minute, which is what I need. And I can do my calculation. 3,000 times 9 milliliters times 1 hour is 27,000 milliliters. 6 times 50 times 60 minutes. 100 minutes, I believe. $7,000 divided by 1,800, giving us 15 milliliters per minute is what we would administer. This is an IV flow rate, which we will spend way more time in when we come back on the 21st. Right now, I want you guys to practice basic dosage calculations and the abbreviations. So the abbreviations, like I said, were page 150 in the book to abbreviate those or to look at what they mean. The homework on those, page 153 through 154. 1 through 15. I'm just going to have you look through all of those. I don't necessarily expect you to memorize those abbreviations, but just go through all 15 of those examples and look up the abbreviations. Make sure you know understand what they're telling you. And then the calculations for dosages, page 162, 163, 1 through 23 the odd. These should all be fairly simple calculations, one-step calculations. So any of the three methods will be pretty much just as easy here, but I do highly recommend you try the dimensional analysis at least to see if you can. It'll make life way easier as we go on. With that, you guys have a great spring break. I will see some of you back on the 21st. Otherwise, I'll see the rest of you when you get back from that. Have a great day.